So continuing with the last discussion on this spectra, okay. So what we had already done is this correlates with 3 protons, this correlates with 3 protons, and this correlates with 2 protons, and it is matching with the formula, that is C4H8. Now, if this is singlet, that means what? It is not having any active proton near it to split. So therefore, if we think like that if this CH3 is bonded to oxygen and if that oxygen is bonded to carbon, then we can have that there is no active proton. But if it is bonded to oxygen, then what we have, this particular delta value will not match with that, because oxygen bonded to oxygen means it will get deshielded, it will be having higher delta value. So this correlation is not matching. Rather, if this CH3 is bonded to the carbon and that carbon is bonded to C double bond O and C single bond O, okay, and then it will be matching quite, because it is having delta value is quite less. So we cannot think of that it is bonded to an electronegative oxygen and hence getting deshielded. So we cannot think of that. Rather, this CH2 is having high delta value, so we can think like that it is bonded to oxygen. So it becomes like this, that it is CH3, C double bonded O, C single bonded O, C double O means C double O, and then it is CH2, CH3 means oxygen is bonded to CH2 and CH2 is bonded to CH3. Means what? It is becoming quadrate because of these 3 protons, and it is becoming triplet because of these 2 protons. Okay, so let us see what is the final answer. So what we find is the same thing, because it is CH3, C double O, CH2, CH3. Now CH3 is not having any protons, hence it is singlet. CH2 is having 3 protons in it, so it is quadrate, and CH3 is having 2 protons, and hence it is triplet. And also it should match with the delta value that is shown in the spectra. Now next is we have an alcohol here. Let's see what is this telling us. So here what we have is the delta value less, very less. We have one triplet. Then a little higher we have singlet, and then we have a kind of quadrate. Yeah, quadrate. Yes, 1, 2, 3, 4. Is it quadrate? Now what we can see, what we can correlate from this is that this OH, let us see this. So what we have, this is CH3 and it is split to a triplet. You can see it is a triplet because of this 2H which is splitting it. Next is this is H2 and it is getting split to a quadrate. As you can see this, its height is also less. It is a quadrate, and this is H and it is bonded to OH, and OH means it will be having little bit higher delta, and this is also having the intensity will be less because it is A1, only single one H is there. The left hand cluster means this one is due to CH2, as you can, it is a quadrate because of 3 hand next to this. You can ignore the effect of OH H group, because why we can ignore, because it is having a gap of oxygen. Oxygen is having there, and therefore it cannot influence. Similarly, OH peak is in the middle of the spectrum. It hasn't turned into a triplet because of the influence of CH2. So it will not turn into a triplet. So this is what here you can see another example has been given. Hydrogen atom attached to the same carbon are said to be equivalent. Now equivalent hydrogen atoms have no effect on each other, so that one hydrogen atom of CH2 does not cause any splitting on the other. But hydrogen atom on the neighboring carbon and atoms can also be equivalent. See here, these two are bonded to two different carbons, but still it is having the same environment because it is having same type of atoms in its neighboring, okay, in its surrounding. So these two hydrogens are even though bonded to two different carbons, it is having same environment, hence they are equivalent. Whereas this one is not having equivalent environment. It is bonded to carbon, it is bonded to bromine, it is bonded bromide, it is bonded to chlorine. Okay, so therefore these are not equivalent, and it will give you two triplets. And accordingly, now this benzene we have already discussed it in the anisotropic effect. This is another example, that is propane. Propane is there. Now this propane, what do we see in this? Here you see this is a triplet, and this is what? This is a haptate, you can say. 1, 2, 3, 4, 5, 6, 7 haptate. Yes, it is a haptate, and this haptate is due to this H2. Its height is very less, so if you add, it will come up to 2 protons, and this is height is more, so it is having 6 protons. Okay, so it is due to this 2H, it is split into triplet. Okay, so also we have done this ethanol. What do you see here is that here it is 3 protons. These 3 protons are having what? It is having surrounding of one neighbor proton, that is, it is having H, and this H will split it to a doublet. Okay, this is doublet, and it is having less delta value because it is not bonded as such with what is the gap? 1, 2, 3, 4. So this is 4 bond gap is there. So there will be little bit of deshielding, but not that much. Okay, because it is not directly bonded to this carbon, which is bonded to an electronegative atom, whereas this H is directly bonded to this carbon, which is bonded to electronegative atom. So this is more deshielded rather than this. So this will have more delta value, and this will have lesser delta value. Now what about this one? This is H, and this is 3 per neighboring protons are there, so it will get split into quadrate. 3 plus 1, 4. So that's all for now. If you have any doubts, please comment in the box in the Google class.